Guys, so I wanted to go over exercise 4 from last week's homework because people really didn't get it right. Um, as I mentioned in the other video I recorded, a lot of people drew the pieces of the graph sort of like on top of each other, which isn't allowed because it doesn't pass the vertical line test. But even when people weren't doing that, they like really didn't seem to understand what this stuff means. So I want to go over the solution that I provided to this problem and explain why this graph satisfies what each of these things is saying. Obviously, this graph is not the only way of doing it. There are many graphs which you could draw that satisfy all these properties, but let's go through each property and see why this graph meets each of these conditions. So the first property is that the limit as x approaches -7 from the right should be infinity. Okay, so here's -7. Now, as my graph approaches -7 from the right, does it go to infinity? Yep, yes it does. As I'm getting close to -7 from the right, the value of the function is going to positive infinity. Okay, that's property number 1. Property number 2, the limit as x approaches -5 from the left is negative infinity. What that means is as I get very close to -5 from the left, so as I get very close to -5 from the left, the value of my function should be going to negative infinity, and it is, right? Okay, so that's property 2. Property number 3 says limit as x approaches -5 from the right should be equal to 2. What that means is as I get very close to -5 from the right, the value of my function should be approaching 2. And you can see that yes, indeed, it is. All right. Most people didn't have problems with those. It's really number 4 and on that people started to have trouble. Number 4, the limit as x approaches -3 exists, yet f is not continuous at -3. Let's first just try to understand what this is saying, okay? This is a two-handed limit because there is no plus or minus above that -3. So by saying that this limit exists, let's remember what is necessary for a two-sided limit to exist. What's necessary is the left and right hand limits agree. It means the left and right hand limits are equal. So in order to make this property be satisfied, I have to draw my graph in such a way that the left and right hand limits as x approaches -3 are the same. That's what it'll take to make the two-sided limit exist. So the left and right hand limits in my graph, let's see what they are at -3. The left hand limit at -3 appears to be 0. Okay? As I approach -3 from the left, the value of my function is going to 0. Now, how about the right-hand limit? Well, as I approach -3 from the right, the value of my function is also 0. And because those left and right-hand limits are both the same number, both 0, that means that the two-sided limit exists. So if you want to draw a graph such that the two-handed limit at -3 exists, then your left and right hand limits must be going to the same value, okay? But then we have this other condition, that f is not continuous at -3. Now, there are many ways for a function to be not continuous, right, at a point. We had this whole thing in the previous problem, or actually exercise number 2, about all the different ways in which a function can fail to be continuous. Let's remember that being continuous at the point C means that the two-sided limit as x approaches C is equal to the value of the function at C. And in order for this equation to be true, in other words, in order for this function to be continuous at C, the left-hand side of this equation must be defined, the right-hand side of this equation must be defined, and the left and right-hand sides of this equation must be equal. That's what the properties 1, 2, and 3 are talking about here. Now, back to our problem in exercise number 4, I'm saying the two-sided limit must exist, and yet the function's not continuous at x equals -3, okay? What that's saying is the left side of this continuity equation does exist, and yet the function's not continuous at the point. You could make that happen in a number of ways. You could, for example, choose to make it so that the right-hand side of the continuity equation isn't defined. In other words, the value of the function is undefined at c. And that's how I chose to do it in my graph, okay? At -3, the function itself is undefined, right? The two-sided limit does exist, it's 0, but the function itself is not defined at -3. That's why we have this empty circle here. There's no black dot anywhere, so if I asked you, what's the value of the function at -3, you wouldn't know. There's no answer to that. So yes, the two-sided limit does exist, but the value of the function, well, there is no value of the function at -3, so it's not continuous. Being continuous means that the two-sided limit exists, the function is defined at the point, and those two things are the same. In other words, the two-sided limit agrees with the value of the function at the point. Okay, number 5, limit as x approaches 0 is defined, and f of 0 is defined, but f is not continuous at 0. Okay, now let's think about why this works. Limit as x approaches 0 being defined, well, what is it going to take for that to happen? Same thing as it took for here, right? For the limit, this is a two-sided limit as x approaches 0. The only way it's going to be defined is if the left and right side limits agree. And they do here, right? As you approach from the left and you approach from the right, you're getting the same value, which means the two-sided limit is defined. Okay, check. Now, f of 0 is defined. What that's saying is my function has to have a value at 0. There has to be like a black dot somewhere above 0. Okay, otherwise it would be undefined. So I got to put a black dot somewhere. I chose to put it here. Okay, so the value of my function at 0 is 1. It says, yet f is not continuous at 0. Now, making it so that the function is not continuous at 0, what that really means is that I cannot put my black dot here. I can't put the black dot right here. If I put the black dot here, then the value of the function at 0 would be 3. The two-sided limit would be 3, and that would make the function continuous, right? But I want the function to be not continuous. There needs to be some kind of gap which forces me to make the value of the function something different from the value of the two-sided limit, right? Okay. Number 6, limit as x approaches 2 is undefined. Well, this is a two-sided limit, right? For this thing to be undefined, that means that the left and right hand limits must be different, right? They must be different. That will cause the two-sided limit to be undefined. And indeed, if you take a look at 2, right here, the left hand limit is 1, the right hand limit is -1, they're different, therefore the two-sided limit is undefined. Okay, I chose to put a black dot here, I didn't have to. There's nothing in this property that says the function has to be defined at 2. I could have left this empty, in which case there would be no black dot above the 2, and the function would simply be undefined at 2. I chose to put a black dot there. That makes it so that my function is defined at 2. The value of the function at 2 is 1, but it doesn't matter. F of 3 equals -2. No one really had any trouble with that. That just means that your function should be at -2 at 3, right? This one here, not too much trouble. People kind of got this. Limit as x approaches 4 from the left has to be equal to f of 4. What that's saying is the value of your function, so this thing here, this is the value of your function at 4, right? The value of your function at 4. This is the value of the function as you approach 4 from the left, all right? Now, if you look in my graph, I put the black dot here. That means the value of the function at 4 is -3. So this thing here is -3 in this case for my graph. This guy, this is the value of the function as x approaches 4 from the left. If I approach 4 from the left, I'm going to -3. Okay, so those two things are the same. As you approach 4 from the left, you get -3, and the value of the function at 4 is -3. So these two things are the same. If I had put the black dot here, it would be wrong, because then the value of the function at 4 would be whatever this is, maybe it's 0.5, and that would be different from the value of the function as you approach 4. And then finally, limit as x approaches 7 from the left has to be infinity. And yeah, indeed, as I approach 7 from the left, it's going to infinity. So I think that, like, you really got to read this closely, okay, and understand what it's saying. Like, it's not enough to have just kind of an approximate understanding. You've really got to see these definitions clearly, okay? And as it says in the notes here, the expression here, very clear, this two-sided limit is only defined if the left and right hand limits are equal. Okay, that's what it means for that thing to be defined. I think a lot of people didn't pick up on that, so make sure we get that clear in our heads. If you still don't understand like why your graph isn't doing the trick or something, shoot me an email, or we can chat over Zoom, or whatever, and we can make it work. But I hope that this clarifies things for people.